It is reported that there is a laboratory called the Super Candy Detector located 1 kilometer underground in the Aikino Mountain in Japan. Since its establishment in 1983, this laboratory has collected a total of 50,000 tons of 100% pure water. But the Japanese are not hoarding water for drinking purposes. Instead, they are using it to search for neutrinos, which are known as cosmic ghosts. What are neutrinos, and why are the Japanese detecting them? Neutrinos are actually a type of fundamental particle, and their movement speed is very close to the speed of light. With the Big Bang that occurred 13.8 billion years ago, the concept of spacetime began to emerge, and at the same time, the 4 fundamental forces of physics were born: gravity, electromagnetic force, strong interaction force, and weak interaction force, among which only the weak interaction force is effective on neutrinos. Some scientists believe that at the beginning of the universe, both matter and antimatter existed simultaneously. However, antimatter cannot be observed due to the influence of neutrinos. If scientists want to study antimatter, they must start with neutrinos because they also carry information about the early universe that predates light. Therefore, scientists must find ways to capture neutrinos. In theory, scientists have a chance to detect neutrinos when they collide directly with quarks inside atomic nuclei. The difficulty of this experiment is like throwing a love letter to your goddess on the ground from a space station, and the letter happens to fall in front of her. On average, 10 quadrillion neutrinos pass through your body every second, and you are completely unaware. Although neutrinos are extremely difficult to capture, when they move in water, there is a certain probability that they react with hydrogen or oxygen atoms. Moreover, the speed of light is reduced by 25% in water, and neutrinos, which maintain a constant speed, can exceed the speed of light, producing Cherenkov radiation. Due to the strong penetrability of neutrinos, Japan has built the Super Candy Detector Laboratory 1,000 meters underground in the Ikuno Mountain, which aims to avoid interference from other cosmic rays and ensure that the Cherenkov radiation produced when neutrinos pass through pure water is accurately recorded. According to astrophysicists' calculations, for every 3 photons produced by the Sun, 2 neutrinos are also generated. However, scientists have only detected 1/3 of them, and no one knows where the remaining 2/3 of neutrinos went. In 1987, the Super Candy Detector detected neutrons from the Large Magellanic Cloud, which were generated in a supernova explosion. Their propagation speed far exceeded that of gamma-ray bursts, and they arrived on Earth 3 hours earlier than the light. However, the number of neutrinos in this event did not show the disappearance of 2/3, and scientists speculated that neutrinos may exist in 3 types that can transform into each other. In 1998, the Super Candy Detector verified this theory for the first time, and its laboratory director, Masatoshi Koshiba, received the Nobel Prize in Physics in 2002. Due to the fact that neutrinos hardly interact with any matter, in many science fiction works, neutrinos are considered to be the ideal means of information transmission, capable of transmitting information to any corner of the universe. In the future, Japan also plans to build another Super Candy Detector, which will store 260,000 tons of ultra-pure water at a depth of 1,750 meters, and its detection capabilities will be several times higher than the current Super Candy Detector.